Remy is here. So in the last video we were talking about BMI as a one way to track the fitness. We've also discussed that BMI has its own disadvantages. So in this video I'll discuss the metric that I will use for my body transformation, and this approach in essence involves measuring the body fat percentage. So why body fat percentage? The reason is because this metric takes in account a composition of muscle or bone and fat, and it allows to plan your diet more efficiently. But the disadvantage of this metric is actually measuring it. It's much more challenging. Let me explain why. I'll use pork chops that I have bought from a local supermarket in order to demonstrate how the fat is distributed in them and what other ways to measure its content. So just to demonstrate the complexity of this problem, let's look into the cross section of this pork chop. And because anatomy of animals, because pig is a mammal and it's not the same as a human, but it's quite similar, we can approximate or model the problem of measuring the human fat by using a pork chop. So as you can see, look at the fat in the pork, at this pork chop. There's a layer here, there's a layer there, and the pink part represents the lean part of the muscle in a pig. So as you can see, it's distributed in the various parts of the pig's body with various length, and it has a complex geometry. So how can we measure this more efficiently? Okay, so first I will try to perform a measurement along the lean part of the pork chop. I will put it on the side here. We'll leave a distance of 1 centimeter between electrodes, and I will count till 10. So once again, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 600. So now let me try another part. But on a fat part. So I'm gonna count till 10 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So about 820. So as you can see, there is a difference, but what we have uncovered is another problem with this measurement, is that they're very inaccurate. So let me try again to put the electrodes in the same pork chop, but let's say we just put it under the water. And we'll count till 10 again. So we'll put it here in this similar place, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 380. So what does it mean for the case of measuring the fat percentage is that the measurement will depend on hydration levels. If you drink a lot of water, your muscle will have more water, and that means that the resistance will change accordingly. So what I'm trying to imply with that is that a lot of scales that use predict body percentage, they use a very similar method, but they don't use actually the resistivity. They use what's called impedance, which is much more complex measure. But the principle is the same, and this method is prone to the same measurement errors. So for that reason, I would say this is not the most accurate method to measure your body fat percentage. So on this note, we can try something else. So another method is called hydrostatic measurement, and it involves measuring a density of the participant in order to estimate the amount of fat tissue. The idea behind it is the fat tissue and a lean tissue would have different densities. So first of all, you need to measure density. For that you need two measures. You need a weight or a mass, and you need the volume. The mass is very easy to measure. We can just use a regular scale, which I will demonstrate by using these pork chops. So what I'm going to do, I'm just going to put pork chops on the scale, which will calibrate. Let's put them there. Just going to change the units. So the total weight is 492 grams, as you can see it here. So once we have obtained weight, the next slightly trickier measurement is to estimate the volume of the pork chops. Obviously, because they have a complex geometry, you can't do it just with a ruler, but thanks God there is a law called Archimedes law that allows to estimate the volume of the body by measuring the displaced water once we put the pork chops inside. So what I have prepared is this apparatus, and this apparatus has this plastic container which will accumulate displaced water, and we also have a jug which we'll later use to measure the volume of that water. So what I do is just going to put the pork chops inside of this container, and as you can see, as we put the pork chops in, we're displacing the water. 2, 3, and 4. And we need to put all of them just to make sure that they completely cover the volume. So as you can see, the water on the bottom of this plastic container is the displaced water, and the volume of this water will represent the volume of these pork chops. Okay, so I removed the pork chops, and now we have all this water, which in theory represents the volume of the pork chops. So I'm just going to put it in a measuring cup in order to measure the volume. And as I can see, the approximate value is, let's see, is 420 milliliters. We have measured the overall density of the pork chops, but what we would like to know is what are the densities of the fat and the lean tissue. So we could use these values in order to reverse calculate the mass and percentage of the fat tissue in the given pork chops. And after that, what we're going to do is just going to take these fat parts and measure on a scale and validate the assumption. So I'm just going to cut them now. Just going to separate. I tried to separate fat as best as I could. So this is the fat tissue. This is the lean mass tissue. So first I'm going to measure the mass of fat. So I'm going to put it here. And the mass of fat is 96 grams. The next step, we're going to measure the mass of the lean muscle. And it's 403 grams. Now the next step is to measure the densities of each, since we know their mass. So we're going to just repeat the same procedure that we did for the whole pork chop. We'll obtain values for densities and we'll try to calculate the mass of fat by using those numbers. We use that displaced water I'm gonna put in a slightly smaller container, obviously because the volume is smaller and it's too small for this jug. It's smaller than 100. Just gonna put it here. That's approximately, let's say, 100 milliliters. Okay. So now we're going to measure the density of the lean part of the pig. We're just going to use again the same methodology, accurately putting them in the water and displacing the pork volume, the lean mass volume. Make sure everything goes in. So we're going to lift it up. So that's the water that was displaced by the lean part of the muscle tissue. We're going to put it here. Obviously, because the volume is higher, we can use this bigger jug. And the value is approximately 320 milliliters. So once we have taken a measurement, we would like to answer a question. If we know the overall density of the body, its mass, and we also know the values for the average density of the fat and lean parts of the body, can we find the body fat percentage? And the answer is that we can. We just start with a simple formula that relates masses and volumes of the body to its overall density, and after some algebraic manipulations, we arrive to the formula that can express a body fat percentage in terms of densities that we do know. We can test it by using the values that we obtain from pork chop measurements, and we can assume that we do not know the masses and volumes for fat and lean parts of the pork chop, only the final results of the calculation. We substitute those values into the equation and we find that the pork chop has a body fat percentage with value 18. We can validate that assumption by simply dividing the mass of the fat part of the pork chop that we actually do know by the total mass of the pork chop. And as we can see, the value is exactly the same, which validates the equation above. However, for human measurements, there's a caveat, namely that the average values for lean and fat parts of the body can differ, as our simplistic experiment only took the muscle part of the pork chop and it didn't account other organs such as bones. For example, the City equation assumes that the average density for fat part is 900 kilograms per cubic meter, which is exactly the same that we have arrived in our experiment, but for lean part, the value is 1,100 kilogram per cubic meter. So we did a couple of measurements using different techniques. So far the hydrostatic measurement is more accurate, but we also have learned that the lean part of the pig is much denser by at least 20 to 25% than a fat tissue. And that has implications for fitness tracking, which means that if you work out and you lose fat, you not necessarily lose mass. You actually can gain mass by simple fact that the lean parts are more denser. The hydrostatic measurements unfortunately are out of reach for majority, for simple reason that not everyone has a big tank at home that would allow to measure the volume of your body. There are probably some organizations that would do, maybe some hospitals or some fitness centers, but at home it's very difficult unless you have a really big bath where you could immerse your body and you could measure the difference in water level before you get immersed and after you get immersed. Okay, so now I'm going to demonstrate a much more simpler way to measure the body fat percentage. It only requires this, a tape measurement, and in essence it requires to measure certain parts of the body, and why I will explain later. So for now what I'm going to do, I'm going to first measure my waist circumference. So the way I'm going to do it, so as you can see, I have a little bit of belly there. I'm going to put the tape around and measure the circumference in the most, biggest part of my waist. So for some people it might be above the belly button. For me, it's going to be slightly below. So I'm making sure that the tape is parallel to the floor. And as I measure, I can see that my circumference is approximately 99 centimeters. So you don't have to do it in centimeters, you can do it in inches, but obviously the calculation will be slightly different. My tape allows to do both, but it's up to you, whatever is easier. Another measurement that you have to do is to measure your neck. So I measure my neck just below the Adam apple, and as I can see, this is 40 centimeters. Now, if you're female, you would also need to do another measurement, and that of hips. You also take the part of the hips which has the biggest circumference, and you just repeat the same measurements. I'm not going to demonstrate it, but it's pretty much straightforward. So how does it work? Let's say I want to calculate my body fat percentage. I take the relevant formula, which is applicable to me, and I plug in values that I have measured before in centimeters. As I plug in, I use my scientific calculator in order to approach to the calculated value. According to this formula, my body fat percentage is 24. In order to validate it, I use an image chart which shows pictures of various individuals which have different body fat percentages. And I compare with my picture in order to understand whether 24% is a valid value. As you can see, my picture corresponds to slightly higher percentage, and that means that this method underestimates the value by a few percent. What I can do is to simply take this, let's say 2%, and add it to this calculated value in order to arrive to the corrected estimate. I will use it from now on, but in 3 months' time I will revisit in order to see whether this correction is still valid. So let's assume my body fat percentage is 26. That means that if my current weight is 89.3 kilograms, my lean mass is 66.1 kilogram, which means that my fat mass is 23.2 kilograms. These values will be useful later when I will calculate my nutrition requirements. But now the more relevant question is how much fat I have to burn in order to arrive to my desired body fat percentage. So I aspire to achieve 10%, and by using some calculations, which are shown on the screen here, I calculate that on assumption that my lean mass will remain the same, my required weight should be 73.44 kilograms. That means that in order to approach to my desired 10%, I have to lose 15.86 kilograms of fat. How much that in calories? Well, in my previous videos, you've seen the assumption that I use that each gram of fat is equivalent to 9 calories. So that means that I have to burn about 142 calories in order to approach to my desired fitness value. As you remember, the BMI method has shown 144,000, and the fact that these two estimates are very similar means that I'm pretty much on the right track. But that also means that if I burn about 500 calories per day, it will take me about 285 days to achieve my goal. We have discussed a couple of methods of measuring the body fat percentage. Some of them are very accurate, but very impractical. Some of them are very practical, but very inaccurate. I have chosen the compromise, just using the tape measurements of my waist and my neck. The good thing about this measurement is that its measurement errors are relatively low compared with systematic errors. But systematic errors are not that scary because they will cancel out as you do measurements in sequence, because you're really tracking the difference between your previous measurement and your current measurement, and you can always correct it by use image cross-referencing. There's another method that I will shortly mention, and that's the X-ray spectroscopy. You can do it in some hospitals or fitness centers, but it's very expensive and it violates the principle of naturality that I mentioned in my introduction, because you will be subject to the radiation dose, albeit a small one, but also it's impractical because you can't do it on an everyday basis. So once I've managed to measure my body fat percentage and I have methodology to do it on a regular basis, the next question is, what should be my goal? I have chosen 10% because I look at the images and I personally think this is the right fat percentage for me. I cannot prescribe for anyone because I'm not a doctor or I'm not a qualified professional to do that. If you research internet, you can find for different gender categories different safety values. If you're male, all what I know is that you can go up to 3%, but that's very, very unhealthy, and you won't be able to last there for long. So if anything below 10%, I would consult a doctor or nutritionist to understand whether it's actually safe to do that. I'm not going to go to that area at all. Also, if you're female, the body fat percentage requirements are very different and higher actually than for male. So that was again to check with your GP or nutritionist. So once we have this fat percentage measurement, we can plan our diet, and we can calculate our metabolic rates, which will be subject of the next video. Meanwhile, I would like to thank you for watching it. Please feel free to comment if you spot some error or you can think of any way to make this video better. Meanwhile, I see you in the next video. Thank you. Bye.